Okay, so now the second video on explaining rising quantities, and we're going to look a little bit more in detail at what happens. So here we've got a model. Households sending labor off to one of two sectors. One is like an immaterial sector, and one is a material sector. Okay, so this is very simplified. In the immaterial sector, we only need labor and maybe some capital. Okay, but it's basically labor. In the material sector, we need labor, we have capital here, some of what we produce, we save and then use as an input, both to the production of goods and to the extraction of minerals, energy, etc., which is an input. Okay, so this is the immaterial sector, this is the material sector, and the product is like ideas here, that's the light bulbs, and cars are representing all the material goods that we're producing. And according to this picture, roughly equal proportions of people are working in each of these sectors. What happens over time? Okay. And how does that affect demand for the natural resource, say oil in the picture, but natural resources in general? So what if labor productivity doubles in both sectors, while consumers demand manufactured goods and services in fixed proportions? Basically what happens here is everything doubles. Okay, you've got the same number of people, but now these four can produce 2 light bulbs per year. These four can produce 2 barrels of oil and 2 cars. Okay, and that would kind of look like the data, right? That GDP would double, everything doubles. GDP doubles, energy use doubles, or resource use. That would look kind of like the data. But there's a problem with this. Because what happens if labor productivity doubles in both sectors, but fuel efficiency also doubles? Okay, isn't that the case, that we've got hugely more fuel efficient? Like if we had an electricity generation here, and think about the efficiency of electricity generation, it's gone up hugely since like 1900 to the present day, for instance. So now, if energy efficiency also doubled, then we should have like 2 light bulbs and 2 cars, but there are 2 cars, they still only need 1 barrel of oil, right? So we should have decoupling, yeah. And of course, to an extent, we see this in countries like Sweden, that energy demand has leveled off. But at a global level, we're not seeing it, okay. And we know that energy efficiency is going up across the globe. Okay. What about if labor productivity doubles in both sectors? Fuel efficiency also doubles. The consumers are price sensitive in their demand for different goods. Well, if they're price sensitive, if fuel efficiency doubles, then we need less fuel per car. That should make the cars cheaper. So then households will buy more cars relative to their services. That's what we call rebound. I think there's one of the things that if someone wants to look at is rebound. The problem with that in this case is that actually fuel costs just aren't that big a proportion, and in general the resource costs, they just aren't that big a proportion of the overall costs. So even if we get more energy efficient or resource efficient, it doesn't affect the price of driving that much. So it doesn't really hold up to say that, oh, because the cars got more energy efficient, we bought loads more cars. Because it just doesn't affect the price of driving quite enough to explain that. Okay. But this is the mechanism that really can make a difference. What if labor productivity doubles in the service sector but goes up by 4 in the manufacturing sector? So labor and capital, those are the really expensive inputs, right? Especially labor. So if labor productivity goes up a lot more in this sector, that pushes the price of these goods down big time compared to these goods, these immaterial goods. And that means that consumers demand a lot more of these goods compared to these goods over time. And that means that that will keep the rate of growth of natural resource demand growing, even though GDP isn't growing that fast, because the overall growth in GDP is the value of this basket which is put together here, and that is very strongly affected by the difficulty of making more of this stuff. What tends to happen is that productivity grows hugely here, and the amount of this stuff we produce goes up hugely, but its price goes down, and actually more people over time work in this sector where productivity doesn't grow as fast. Okay. Pretty tricky, but that is Baumol's disease. Okay. And the paper by Kander actually is pretty nice. It's not that hard. Okay. It's in the journal Ecological Economics. It's not super technical. So I'd recommend it. Yeah, it would be super nice if some of you wanted to have a look at that. Knittel is about the way that cars have got in the US, the technology has improved, making them more fuel efficient, but at the same time, people have chosen heavier and heavier and more powerful cars. So that is a kind of an illustration of this effect, that as cars have got cheaper, people in the US anyway have chosen bigger and bigger, heavier and heavier, more and more powerful cars. Fouquet and Pearson is about light, especially, which I'll talk about shortly in the next video. And then Gillingham is about this rebound effect, that if we increase, say, fuel efficiency here, how big an effect does that have on these prices, and how much extra consumption do we see, which then reduces the original effect of the efficiency increase. That's the Gillingham et al. Paper. Okay, so that's basically that, explaining rising quantities. This is the key explanation, that resource-intensive goods, labor productivity tends to grow faster in these sectors than in these sectors. This is where the university lecturers are, right? So labor productivity grows faster here. The prices of these goods fall. We buy loads more of them over time, which pushes up resource use despite efficiency increases. Okay, quite tricky, but I hope you get it more or less. We'll talk about it in class as well, I'm sure. Okay, yeah, I'm going to stop this one here.